Hi everyone, the next section of the Dynamics in Space topic is on forces, and this video is going to talk through a brief introduction. A force can be described as a push, pull or twist on an object. You'll see for the animation that a force can be represented with an arrow showing the direction of the force, and in some cases the arrow also indicates the size of the force. Forces are measured in newtons, named after Isaac Newton, who you saw at the beginning. And the famous story about him is that he allegedly came up with all his theories on forces after sitting below a tree and an apple fell on his head, and apparently gave him the inspiration for all of his theories on forces. So forces are measured in newtons after him. Forces can have different effects on objects, and the key ones that you'll see from these examples is that forces can change the speed, the direction, and also the shape of objects. And you'll also notice on some of the diagrams at the bottom that arrows are being used again to represent how the forces are acting on the object, showing the direction and in some of the cases showing the size of the force as well. We're also going to be looking at friction, and friction is also a force, and it always acts in the opposite direction to motion. So you can see from the animation they're pushing the block to the right hand side of the screen, and you'll notice an arrow appearing at the bottom of the block pointing left. So they're trying to push the block to the right, and while they're doing that there's friction between the block and the floor, acting in the opposite direction to the left. And obviously in this case friction is a problem because it's making it difficult for movement to happen. However, friction can also be useful. So in this one here we can see that if there was no friction, then you wouldn't be able to move forwards at all. So friction is a force. It opposes the motion of an object. It always acts in the opposite direction to movement. And friction, whenever there's friction between two surfaces, that produces some heat energy. And in some cases, that's not always useful. If you're rubbing your hands on a cold day, obviously the friction and the heat produced is useful. If you've got moving parts of a machine or an engine, sometimes the heat is not so useful. We're also going to look at balanced and unbalanced forces. So balanced forces are forces that are equal in size but opposite in direction. That's when we have balanced forces. And obviously the opposite from that would be unbalanced forces, when one force is greater than the other.